Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Harith bin Mohamad Salih, and my metric number is AE190033. And my supervisor is PM Dr. Wahyu Mulyo Utomo. And my title for the final year project 1 is the design bug converter for DC motor transporter application with IoT system. So we're gonna take a look for the background of the study. So the first background study that the equipment have the equipment has component known as a buck converter that is necessary to convert from high voltage to low voltage, and the efficiency of this kind of equipment is a very high at about 90%. And the second the second of the this uh, study is that the buck converters are frequently used to supply low voltage onboard power in range of applications including microprocessor, communication equipment, control system, and more, in place in conventional efficiency linear regulator. So you can use it with the low voltage equipment like a USB, Arduino sensor, and other things. Even though it's from the high voltage source. Next is the network of physical items or things that are implemented with sensor, software, and other technology for the purpose of communicating and exchanging data with other device and system through the internet. This is called IoT, Internet of Things. So we use internet to give information about what happened to the equipment or other things. So the problem statement that all the equipment have a has a heating issue, and it can make the battery life or the I would say the battery, because it's from 12-volt battery, shortened lifespan. Uh, and this other thing is for the IoT. It's very hard for human to do all the work, and human can easily make an error very easily. And always need to keep monitoring every second and controlling it at a short distance. This is very problematic when it comes to controlling the machine and others. So that's why Internet of Things is very useful for to the this kind of industry, because we are in the new era. So this is very important. So the objective is to design. The first objective is to design the simulation of the buck converter for DC motor transport application. Second objective is to design buck converter circuit. And third is to control a buck converter for DC motor transporter application using IoT. So scope of study, firstly is that for the microcontroller is using Arduino and require power supply of the battery with a 12 volt. So actually Arduino is using require 5 volt, but it's from the supply of 12 volt, and the buck converter came in handy with this station. So maximum power of the motor is 200 watt and have 12 it. So it's control the movement of the transporter. The IoT system is using non-MCU ASP8266. So that is the main IoT system we use. And the system of microcontroller will be programmed by using an Arduino, and the buck converter will be used the MATLAB simulator. So we go through all the review that I have written. So the author for the first is Silva Ortigova, and others group members is a lot of members, and the year published is 2013, The title is two-stage control design of the buck converter DC motor system without velocity measurement via modulation. Mathematical problem in engineering. So the summary in this paper, I can help to maintain the angular velocity of the DC motor and can be measured the speed even without the sensor. So next is the Silva Ortigova and the others group members, and the year of publication is 2016. DC-DC buck converter as a smooth starter for a DC motor based on a theoretical control. So the summary is the DC buck converter DC motor system angular velocity to the track issue was addressed. So the two problem is that the first is concerned with controlling the DC motor, and the second is concerned to controlling a buck converter. And all the information that occur in this paper can be prevented if I have a same problem during the process of making this research. Not research, this project. So next is Kubawa Kubalka S. And the year publisher is 2016. The title is Design and Realizing of Standalone Digital Fractional Order PID Control 30 for Buck Converter Fed DC Motor Circuit System and Signal Processing. This is to make a reference for the my PID control in the MATLAB simulator. So Albira M and Azharni A and Zohdi M. We are published in 2020, and the title is Model Predictive Speed Control of DC-DC Buck Converter Driven DC Motor with Various Load Torque Value 2020. So the summary is the suggested technique make use of the input control signal and is provided to the buck converter to modify the required output voltage and current as well as the output feedback signal to MPC to anticipate the state data. And lastly, the Gerstenatchev M 2020. And the title is IoT based DC-DC Deep Learning Power Converter Control Real-Time Implemented. So the summary is the combination of buck converter and IoT technology can help me to understand how the system functions and help me solve any difficulties and that arise in the research that is similar to them. So we go to the methodology. So for the first step is like previously reviewing a lecture review. And next is to design a DC-DC buck converter using MATLAB. So the process here, if I cannot have require the certain value of the voltage, so I gonna repeat it to design it again. And if it require to have to lower down the voltage, so I gotta go to the next step is to design a wire circuit for the buck converter. So I gotta observe the output voltage of the buck converter. It is the same as the simulation. Next is to create a coding on Arduino for the IoT system in the application. So check if the coding is correct. If no, recreate it back. If yes, design the hardware circuit of the IoT system. And finally, analyze all the overall project and result. So these are the block diagram that I used for the buck converter in the MATLAB simulator. So here we can see the power grid, the two from MOSFET, diode, inductance, capacitance. This is a load, resistance. We have a PID control, constant. We have frequency sequence, saturation, and scope. So this diode and inductor is function to smooth out the the output voltage. MOSFET as a switch to turn on, turn off. So this is constant. So if we that's for the result. Very control. Saturation is here like we limit it to 1 and 0 only because the PWM or have the range is from 0 to 1. This is sequence more than equal to, so we can just take the upper we can take just the upper part of the wave. So for the result here we can see three waveforms, the PWM, inductor current and output voltage. So you can see here in the PWM the range is from 0 to 1 is and the inductor current here is very smooth, very accuracy, and the output voltage. So we know that for this simulation, the input voltage is 12 volts, and I setting the output voltage is 5 volts. So we setting here in the constant. So for this diagram, so let's see here, I setting it 10, it become almost 10. So same you goes here. Uh, Setting 5 volt is almost the 5 volt. Is you can see here is a DC current, so it's a straight line. So this is result for output voltage. So here you can see using a different type of constant. So this is constant. This constant are using a 5 volt. This constant are using 7 volt, and this constant are using 9 volt. And the result is here almost 5 volt, 4.9, almost 7 volt, 9, 6.9, and this is almost 9 volt, 9.9. So that's it. That's all from me. Thank you.